Welcome everyone, my name is Harshit Sridharan and I'll be your narrator during this presentation regarding the fascinating macromolecule of cortisol. During this presentation, you'll be hearing multiple facets regarding cortisol, including the basics to get us started. We'll talk about the synthesization of cortisol and the biochemistry behind it. We'll be talking about the metabolic responses regarding cortisol, some of the common symptoms, whether it be regarding high or low levels of cortisol. And our main focus for this presentation will be the secondary effects that cortisol has on our bodies. And then finally, we'll be talking about the regulation of cortisol. Now let's talk about the basics of cortisol. If you don't know what cortisol is, don't worry, the definition is right here. Cortisol is a steroid hormone produced by the adrenal cortex, and the adrenal cortex is located above the kidneys. Cortisol is essential for the maintenance of homeostasis. Its chemical formula is C21H30O5, and its molecular mass is approximately 362.46 grams per mole. If you're not sure, or if cortisol, the name rings a bell, you've probably heard it said as being the stress hormone. Unfortunately, stress is something we deal with on a daily basis. Now let's talk about the structure of cortisol. On the left, you'll see a 3D model of cortisol, and on the right, you'll see a 2D structure of cortisol. It's important to note the functional groups in cortisol. We have 2 alcohol groups, 2 ketone groups, and 1 alkene group. The alkene being a carbon double bond. And it's important to identify the black atoms as being carbon, white representing hydrogen, and red atoms representing oxygen in the 3D model to the left. Now let's talk about the biochemistry and the synthesization of cortisol. First of all, cortisol is synthesized mainly from cholesterol. The synthesization takes place in the adrenal cortex, and the adrenal cortex also synthesizes other hormones, including aldosterone and other sex hormones. Its synthesis is stimulated by the anterior lobe and pituitary gland with the aid of the adrenocorticotropic hormone, otherwise known as ACTH. ACTH increases the concentration of cholesterol, in turn stimulating the main step in cortisol synthesis. Now, the release of cortisol is controlled by something called the hypothalamus. After multiple processes, ACTH is produced and made and flows through the blood into cortisol, as you can see on the right, in the image in the right. ACTH is pushed into the vascular system, the blood, and stimulates cortisol as well as the dehydroepiandrosterone, better known as DHEA. Again, on the right, you can see the major pathways starting with cholesterol and ending with the cortisol or glucocorticoids, as they are called. Now let's talk about the metabolic response that cortisol has. First of all, cortisol stimulates gluconeogenesis, which is the formation of glucose. This activates anti-inflammatory and anti-stress pathways, similar to the pathways mentioned in the slide prior. Cortisol also has an important role in the liver and muscle glycogenolysis. And that is the breakdown of glucose to glucose 1-phosphate and glucose. So the breakdown of glucose to glucose 1-phosphate and glucose. Elevated levels of cortisol can also lead to proteolysis and even have lipolytic effects. That is the breakdown of proteins and the promotion of the breakdown of fats. As you can see on the right, this is the pathway that occurs when synthesizing cortisol, which we will be talking about later as well. It starts with the hypothalamus, then to the pituitary gland, the ACTH, adrenal glands, and then finally cortisol. Now the metabolic response has 3 main categories: glucose, bone and collagen, and amino acids. In relation to glucose, cortisol counteracts insulin and contributes to gluconeogenesis. It also increases glycogen synthesis in the liver, as mentioned earlier. In regards to the bones, cortisol reduces bone formation, favoring the long-term development known as osteoporosis. It does this by transporting equal number of potassium and sodium ions into and out of the cell, as shown in the image to the right. Regarding amino acids, cortisol raises the free amino acids in the serum, inhibiting collagen formation and decreasing amino acid uptake, and therefore inhibiting protein synthesis. Now, before we go further, it's important to note some of the common symptoms for high levels and low levels of cortisol, as these will have already been mentioned and will be mentioned later on in this presentation. For high level of cortisol, some of the symptoms include high blood pressure, fatigue, weight gain, insomnia, and poor concentration, while low levels, some of the symptoms for low levels include sugar and salt cravings, anxiety, weight gain, bone and muscle loss as mentioned, depressed mood, fatigue, and so on. So these are some of the common symptoms that high and low level of cortisol may have on you. So now let's focus on the secondary effects, the effects that really have on our bodies. First, let's talk about memory. Cortisol works with epinephrine, which is adrenaline, to create memories of short-term emotional events. Cortisol is also proposed as a mechanism for flashbulb memories. Flashbulb memories are highly detailed, vivid snapshots of a moment or circumstance in which a surprising piece of news was heard. And as you can see with the chart on the right, it is organized by emotional intensity. As you can see, the medium and high level intensities have a much higher accuracy rating, even 3 months, 18 months away from the event or the circumstance. Those accuracy ratings are much higher than a low intensity moment, proving that flashbulb memories, that is the mechanism, cortisol is a mechanism used for remembering these flashbulb memories. Long-term exposure to cortisol, however, can damage cells in the hippocampus, leading to impaired learning. Cortisol may also inhibit memory retrieval of already known information. Now, something to note here is that even looking at this first secondary effect in memory, we can see that cortisol has very good effects in remembering flashbulb memories, but also has some not so great effects, some negative effects, leading to impaired learning and even inhibiting memory retrieval. So cortisol has good and bad, which you will see later on. So that's something to keep in mind. Now let's dive into the main component or secondary effect that cortisol has. Even at regular levels of cortisol, cortisol has connections to clinical depression, psychological stress, illness, trauma, fear, pain. These are things that obviously we don't want, and even with regular levels of cortisol that you and I have, we are exposed to these types of things. However, cortisol helps us deal with this stress as well by shutting down unnecessary functions, such as the reproduction system or the immune system, things we don't need every minute of our lives. So cortisol will shut these systems down and these functions down to help us cope with some stress. However, it's important to note that too much stress will lead to too much cortisol. And with too much cortisol comes many things. As we've already mentioned, too much cortisol can lead to excess of glucose, excess blood flow, and have detrimental effects on your bones and your muscles. Now, when all this happens, when there's too much stress, when there's too much cortisol, cortisol actually shuts off its mechanisms. And obviously that limits the production of cortisol, which is detrimental for us. So what happens, again, going back to the synthesis here, it starts off in the hypothalamus. So when the hypothalamus detects some kind of stress that you may be having, it produces corticotropin-releasing hormone, otherwise known as CRH. When that is produced, it stimulates the pituitary gland to produce the adrenocorticotropic hormone, ACTH, as we mentioned before. That in turn stimulates the adrenal gland to produce cortisol. So after all of that, after this process, after it goes through the blood, cortisol is made. And so essentially it's a chain system, and the message is a message is sent from the hypothalamus all the way to cortisol. What happens when there's too many stresses and too much stress that you may be dealing with is that the hypothalamus basically tells all of its components, all the way until cortisol to stop, because the system has been overloaded. And when this happens, when there's too much stress, this limits the production of cortisol, which increases stress, and other negative symptoms like we mentioned before, like fatigue and sleep deprivation and things like that will increase because there's not enough cortisol in your body. Now regarding sleep deprivation, cortisol undergoes a cycle called the diurnal cycle. What happens is that in the morning, what actually helps you get out of the bed isn't your alarm, but it's actually cortisol, because cortisol reaches its peak, the peak cortisol release at 8 a.m. in the morning, around 8 a.m. in the morning. And throughout the day, it declines as you gain stresses in everyday life, and you do things and you're active. Around 3 to 4 a.m. in the morning, it's at its lowest. And when you go to bed even, it's nearing its lowest point. Now this is caused because the retina, it transmits the light and dark cycles that you're living on a daily basis to the hypothalamus. And again, the hypothalamus is the beginning of that chain to synthesize cortisol. Now, cortisol, one of its interesting secondary effects is wound healing. High levels of cortisol through research have been found to lengthen wound healing. And an experiment showed that college students, so college students were in an experiment with a punch biopsy. And what happened is that there were 2 times that they had this punch biopsy taken. As you can see on the right, that's a punch biopsy. They had 2 times, one 3 days before an exam, and one during summer vacation. And we know so far that 3 days before an exam, you'll be very stressed out, which means there will be a high level of cortisol. And what they detected was that the same students who had their punch biopsy taken 3 days before the exam, the wound took 40% longer to heal. While if the same experiment conducted in the summer vacation when cortisol levels are low was 60% faster. So this experiment was conducted multiple times with several groups, several focus groups, and wound healing was evident in this. So that's an interesting revelation, as some hormone could have physical effects on your body, and cortisol is that hormone. Now, there are many things that you can do to regulate cortisol. Obviously, we don't want to increase cortisol, but however, if you have a viral infection, if you're engaging in intense exercise, if you're going to the gym a lot, if you're sleep deprived, if you've just encountered a severe trauma or a stressful event, or you even drink a lot of Diet Coke, or regular Coke, that might increase your cortisol levels, and that's not what you want. But there are many easy ways to decrease cortisol levels as well. And essentially, this category is also telling you how to decrease your stress levels. So something you can do to decrease your stress levels and decrease cortisol is have a massage therapy, or music therapy. You can also try black tea or soy-derived phosphatidylserine, which some of those include tuna, chicken legs, beef, carrots. So those foods will decrease your cortisol levels, as well as omega-3 fatty acids, which include fish, eggs, chia seeds, and those kinds of things. You can also try laughing. Engaging in some kind of humor will also help you decrease your cortisol levels. Now let's recap what we have learned in this presentation. We learned about the structure. We learned about the structure, the 3D model that we saw, and the 2D model, and we noted the functional groups of 2 alcohols, 2 ketones, and 1 alkene with the double bond. We learned about the structure of cortisol. We also learned about the synthesization, how it all starts with the hypothalamus. travels down the chain, travels through the ACTH, through the vascular system, through the blood, all the way to cortisol, sending messages when you get stresses, when you get some kind of event. It triggers that chain. We saw that. And we also looked at the metabolic responses in terms of synthesization. We also looked at some of the common symptoms with high and low cortisol levels, which included fatigue, high blood pressure, sleep deprivation, and things of that nature. We also looked in depth into secondary effects. We looked at sleep, we looked at stress, we looked at memory, we looked at wound healing, and 4 main components that cortisol has on our everyday lives. And we also looked at, lastly, easy ways to regulate the amount of cortisol in our bodies. And this was something that we all can do on a daily basis. As you can see, again, this wheel shows the effects of excess cortisol to our body, and all of those things that are mentioned are things that we can control. So cortisol is something that is really in our hands to control. I'd like to thank you for watching this presentation, and I hope that after this presentation you know everything you need to know about the macromolecule cortisol. Again, thank you for watching, and have a great day.